Pre-calculus students, welcome to section 10.2, the first section that we study in chapter 10 on conic sections. When you have time, please check out the little animated applet that I included on Schoology in chapter 10 just to see how conic sections are formed from using two cones, hence the word conic. I'll probably also play that in class. Today, we're going to look at parabolas. Circles are kind of what we call the first conic section, but we have studied those over and over again. And so in pre-calculus, we focus on parabolas, ellipses, and hyperbolas. So why do we study conic sections is because they occur everywhere in the world, right? Circles, parabolas are paths of our projectiles in the shape of our eyeglasses and our satellite dishes, and ellipses, of course, are our orbits and also shapes that we make in the world. And hyperbolas are the way that noise travels and light. And so we study these because they really occur in our world. So the definition of a parabola, it is the set of all points in a plane that is equidistant from a fixed line. That's this dashed line here called a directrix, and a fixed point called the focus that's not on the line. So the interesting thing about a parabola is all of its points are created on this plane from a line and a point that aren't on the parabola at all. So what does this actually mean? It means if you take a look at this parabola here, here's the vertex. Here is the point that is the focus, always on the inside of the parabola, and the directrix, always on the outside of the parabola. And by the way, always going in the opposite orientation of the parabola. Notice the directrix is a horizontal line and the parabola is vertical. It is opening upward, right? So notice that any point on the parabola, like the one you see here that I marked XY, is equidistant from the focus and the directrix. So I drew a distance from the focus to the point on the parabola and from the point on the parabola to the directrix. And notice they are the same length, right? If I drew another XY point up here, notice here's the distance from the focus to the point on the parabola. And here is the distance to the directrix, and those are also the same distance. So we have studied parabolas before, but this time we are going to also be looking at parabolas that have a horizontal orientation, parabolas that have a vertical orientation, open upward or downward, and the y is to the first power and the x is being squared, right? In parabolas with horizontal orientations, the x is to the first power and the y is being squared, right? So notice that on y equals x squared, the point 2 and 4, right, make the parabola true, right? So here's 2 and 4, right? And also -2 for your x produces a 4, right? -2 and 4. What happens when you have a parabola that opens horizontally, either to the right or to the left, is notice that if your x is 4, that means that your y can be 2 or -2, right? So this creates the point 4, 2, which is right here, or 4, -2, which is here. And that is how, when the y is being squared instead of the x, you get a horizontal parabola based on the points that make the equation true. So characteristics of a parabola: the directrix and the focus have opposite orientations. Okay, actually, this is supposed to be the directrix and the parabola. There we go. The directrix and the parabola have opposite orientations. The focus is always inside the parabola. This will help us with drawing. So how do you do these problems? You use your formula sheet. Here's your formula sheet. I have it in my hand, and you should have yours in your hand also. To find the orientation of the parabola, and then either we have been given a graphing equation and we're asked to find the characteristics of the parabola. So we would find H, K, and P from the equation, right, or the parabola, and sorry, my brother was right there and I was looking at him. Hi, brother.
Hello.
Okay, let's do that again. So we find the orientation, so we know which type of equation and graph we're looking at. And then either we use our characteristics of the parabola to find the variables H, K, and P, or we have H, K, and P in the equation of the parabola. There's H, K's, and P's to find characteristics. So either one way or the other. So either basically you've been given an equation and they're asking you to graph it and give characteristics, or you have a graph and you're being asked to write an equation. So we're just going either way. So here's our examples, formula sheet in hand. Here it is. And here is problem number 20. It says find, I abbreviated to save room. This is the standard form of the equation with parabola with the given characteristics, and on number 20 they give this picture and a vertex. I just thought I'd put a V there because you'll get used to V is vertex, C is center, F is focus, so we don't have to keep writing these things out. D is directrix. So with a vertex at 0, 0, notice that is the vertex there. So again, find the standard form of the equation for the parabola with given characteristics here and a vertex at 0, 0. So when I take a look at my sheet, they've asked me to write an equation. I need to know which equation to write, right? Because if I have a vertical orientation, my y will be to the first power and my x will be squared. Or if I have a horizontal orientation, my y is being squared and I have x to the first power. I see if I have a horizontal orientation, I look at my sheet and here is my standard form of an equation with horizontal orientation. And so I write it because now I can see, right, what my goal is here, okay? If I can fill in the H and the K and the P, then I am done writing this equation, okay? Now, notice that, that the vertex is 0, 0, and that is HK, right? So when you look on your paper, there you see the vertex is HK, and my vertex is 0, 0. So here we go, 0 and 0. Okay, well, I'll be done writing if I have the P. And the way I'm going to find P in this case is they did give me an XY point that makes this equation true. So I am going to put in -2 for X and 6 for Y and solve for P. So what I have right now, I don't really need the -0, right? Though it's perfectly fine. I don't really need the -0s here, right? So here's Y squared. There we go in our X. Again, didn't need -0 here or here. So I am going to put in -2 for X and 6 for Y. And I'll do that math here. 6 squared is 36 equals 4 times P. My X is a -2. There we go. So I have that 36 equals a -8P, right? And I'll divide both sides by a -8. So notice I get P equals 36 over -8, right? And so I'm just going to reduce that. I can take a 4 out of each. So when I divide by 4, that's 9 halves. So a -9 halves, or 4.5. There we go. So I'm going to go back up and put in for P. I guess I'll come on over here. Here we go. Y equals, here's my 4, always part of the formula. My P is a 4.5 negative, and my X is here. There we go. Just a little bit of math to do. Then a negative 4.5 times 4 is 2 times a negative 9, so a negative 18x. Notice it does make sense that my P is negative because the P gives the orientation. If my P was positive, my parabola would be going to the right. But because my parabola is going to the left, you'll see that that P is negative. And so this is the final equation that they asked us to write for this parabola. Hi, we're moving on to problem number 24. We are asked to find the standard form of the equation of the parabola with a focus, that's what the F is for, of 0, -2, and a vertex of 0, 0. So again, I need to know the orientation of this parabola so I know whether to write a horizontal equation or a vertical. So I'm going to draw a picture of what I have right now, right? So the vertex is at 0, 0, right? I label that with a V. And the focus is at 0, -2. Okay. Just because of what I see now, I do know that this parabola opens downward because the focus is always inside of the parabola. So I know that my parabola goes downward. That is a vertical orientation. And I know when I'm done writing the equation that my P in my equation will be negative because the parabola goes downward. If the parabola went upward, the P would be positive. Okay, so I have the notes in my hand and I'm writing the equation for a vertical orientation for a parabola. Notice right here, x minus h squared. Notice that that is a perfect square. We're going to need that later. Remember, we learned how to make perfect square binomials. Anyway, we won't need it in this problem, but just wanted to point it out for P, y minus k. So notice again, because our vertex is 0, 0, and a vertex is located at HK, that our H is 0 and our K is 0. So let's put those in. Now, if we just had P, we would be done writing this equation. So what they gave me is the focus. So I'm going to use that. If you notice, right? So I'm only looking in the column for the information on a vertical parabola, that the focus is HK plus P. I'm going to write that because they gave me information for that. H and K plus P. And I'm going to write the focus that they gave me right underneath it. This will help me compare. Now notice that my H and my K were 0, right? So just trying to erase, wish I had a little eraser. This is 0, right? 0 and 0, right? And 0 plus P is P. So notice that just by matching up the formula for a focus and the focus they gave me, I can see that P is -2. And I'm going to put that into my equation. Notice again, it makes sense that that P is negative. There we go. So I actually have everything I need right here to write my equation. I'll bring that down. X squared on the left, I don't need -0, equals -8 times y. It is possible that in the book they got the y alone and divided both sides by -8, but they asked for the standard form of the equation, and this is. Let's try problem number 26 next. Okay, here we are on problem number 26. Same question, standard form of the equation of the parabola with a directrix of y equals -2 and a vertex at 0, 0. Pretty soon the vertex won't always be at 0, 0. And take a sip of Diet Coke. All right, let's take a look. We need to know the orientation. And here's my clue right here. The directrix is y equals -2. So I look on my parabola sheet, and under horizontal orientation, I look for the directrix, and it says x equals h minus p. Okay, so it must not be horizontal. Because we have y equals. So let's go to the vertical orientation. And when we go to the directrix, it says y equals k minus p. So our parabola must have a vertical orientation because it matches the form of the directrix. Right under the directrix here, I am going to write the formula for it that is on my sheet because I am sure I will need that later. Okay, so again, vertical orientation. So I'm going to write that formula. If I fill in the h, the k, and the p, then I will have written my equation. Again, the vertex is 0, 0. And if I just had the p, I would be all set. So I'm coming on over here to use the information on the directrix, right? So I said that my k was 0. And let's take a look here. 0 minus p is just minus p. So take a look here. It must be that my p is 2, right? Because if I put a 2 in here for p, then it matches my directrix equation. And so I'm going to put a 2 in here for p. And I get x squared equals 8 times y. And there, I wrote the standard form of the equation of my parabola. Let's try number 60. Okay, let's look at problem number 60. They are asking us to find the standard form of the equation of the parabola with a focus at 0, 0, meaning finally our vertex can't be at 0, 0 because the focus is inside the parabola. Our vertex must be located somewhere else. And a directrix of y equals 8. Okay, as always, the first thing I need is the orientation of the parabola so I know what equation to write. The focus doesn't help me, right? Give the orientation because that focus could be in a parabola going left, right, up, or down. But here again, at the directrix, y equals 8. When I look on my sheet, I see a directrix that's y equals is vertical. So I'm going to go ahead and write that equation. There we go. And if I had the h, the k, and the p, I would be done writing this equation. So I'm going to use the information they gave me on the focus and the directrix. So what I'm going to do is look on my sheet and the formulas for the focus and the directrix, I'm going to write right underneath, right? So the focus is h and k plus p. And the directrix is y equals k minus p. Okay, so let's see if we can use this to help us. Okay, first of all, I can see that h is 0, right? So I will put that there. Now, what I have going on here is to figure out p and k. I have 2 pieces of information right here. K plus p equals 0, right? And k minus p equals 8. So it looks like I have a system of equations to solve. So I'm going to go ahead and do that and solve for p and for k. And then I just want to talk a little bit about using logic rather than systems which actually sometimes you need them, but a little logic helps also. Let's take a look. When I add up these two equations, because the p's eliminate, I get 2k equals 8, and I get k equals 4. There we go. And I'm going to put that right here for k. And now that k is 4, I can put it back into the equation. Here, when I put a 4 in, then 4 plus a negative 4 is 0. So p must be negative 4. There we go. And I have x squared equals negative 16 times y minus 4. So there we go. Not too bad, right? Super easy. But I did just want to point out to you, let's come back over here. Here's what I see in my picture. In my picture, my vertex is the same distance from the focus that it is from the directrix, because that's what a parabola is. It is all the points that are equal distance from a focus and a directrix. And in fact, this length is called P right here. Okay, so I actually could have figured this out. If you have the point 0, 0 right here for the focus, and the directrix is up at y equals 8, then the vertex must have been in between there, and that would be at 0, 4. So we kind of knew, like, just you can use logic also to say that our k, right, that the vertex was 0, 4, right? But the system worked also. And one last problem. All right, class, number 46, last problem. They give us this equation for a parabola. Notice it's not in the standard form for horizontal and vertical that you see on your sheet. We are going to need to put this equation of this parabola in standard form. Then we need to find the h, the k, and the p so that we can write the vertex, the focus, the directrix, and to graph it. These are all the things that they've asked us for. Okay, so a parabola has either the y being squared or the x being squared. Notice in our case that the y is being squared, right? I always need the orientation first, so I know what parabola equation I'm writing. That would be a horizontal orientation. So that would be horizontal, right? So on my sheet, I will be writing y minus k squared equals 4p times x minus h. So I need to write this equation of my parabola in this form so I can find h, k, and p and answer their question. Okay, so here we go. First of all, notice on the left that we have a perfect square binomial, and we know how to make that happen. Notice that my x's are on the right. So the first thing I'm going to do is add 4x to both sides, just so we have our x's and our y's in proper places. The next thing I'm going to do is write a perfect square trinomial, because we know how to do that right here, right? Remember doing this? So we can write it in this binomial squared form. So I'm going to take half of b, so that's negative 2 squared is 4. And I'm going to add a 4 here and here to keep both sides equal. So I know how to write this in the binomial squared form. It is y followed by half of b. And notice what I'm going to do here is they do have the constant factored off the x on the right. The x is to the first power. So I'm going to factor a 4. There we go. Okay, I think we can get our variables now. Notice, let's get our h. So our h must be right here, right? So h minus h matches to a +1. Well, notice a +1 is minus a -1, right? We saw this with circles before. So my h must be a -1, right? My k is with the y and follows a minus sign, and it must be a 2. And my p, if you take a look here, 4p has to equal 4, meaning my p must be 1. So what we're going to do now, I always put a box on these 3 variables here because I don't want to look anywhere else. H, K, and P give me the next 3 items, and I am going to just look here, okay? The vertex is HK, and my H is -1, and my K is 2, right? This was horizontal, right? Making sure I'm looking in the right place. My focus is H plus P and K. Okay. H plus P, -1 plus 1 is 0. My K is 2. The directrix is X equals H minus P. And my H minus P is -1 minus 1 is X equals -2. There we go. So far, I have answered everything they wanted from me except to graph this parabola, okay? So I haven't left myself much room. So I'm just gonna hit pause and erase to the left so that we can graph. Okay, let's start graphing. So for all this information I have, only a little bit of it really helps me graph well. And this because the focus, I know is inside the parabola, but the directrix isn't on it, and neither is the focus. But I do have the vertex. So let's start with the vertex, right? So here's our graph. All right, so our vertex is at -1, 2. Right, and I'm going to label that the vertex. Now, I do know because P is, this is a horizontal parabola, right? And because P is positive, I do know that this parabola opens to the right. How else do I know? The focus is located at 0, 2, which is right here, right? And so the parabola opens because the focus is always in it. So the parabola is horizontal and opens to the right. Okay, here's the thing. Nothing here is really telling me how wide the parabola is. And that's the last thing I need. Like, is it very narrow? Is it very wide? So a couple ways to go. You could either solve for y-intercepts by putting x equals 0 into our parabola equation right here. Let's give a circle there. Let's put stars on there, right? Because we can see that our parabola is going to come across the y-axis. Another thing we could do is we can also see that our parabola is going to hit the x-axis at some point. So we can also put in 0 for y and solve for the x where that happens and uses symmetry, okay? In this case, let's go ahead and get the y-intercepts by putting in 0 for x and see what we get, okay? So let's take a look. When I put, I'll write my equation here, y minus 2 squared equals 4 times x plus 1. And we're going to put in 0 for x because that will give us our y-intercepts. Notice that this would be 1 times 4, so this would be y minus 2 squared equals 4. Okay. I'll take the square root of both sides, and I won't forget to put my plus or minus. And I have y minus 2 equals plus or minus 2. And I'll add a 2 to both sides. There we go. So our y, we have 2 of them, but that's not surprising. We knew there would be 2. Would be plus 2, which is 4, minus 2 plus 2, which is 0. So we have a y of 4 and a y of 0. Again, notice the symmetry from the vertex. Notice that makes sense. There we go. And now we can finish graph. There. And now that is your basic lesson on parabolas. Have a great day.